Okay. You coming back from school every day. You are going to school every day.
What, uncle?
Are you going to school every day or alternate days?
Every day, every day, every day.
Every day. Many schools are having alternate day schools.
Yeah, uncle. But for my school, it's every day only.
Every day only. Okay. Now, yesterday we were talking about the general linear programming problem. Okay, there are two things. One is the critical path management tool, which is CPM method and project management. The other one in operations management is linear programming problem. Okay, in linear programming problem, what we have is some condition which needs to be maximized or minimized. For example, let us say under industrial, you are working as a manager in a factory. At that time, they are asking you to maximize the profits. Okay, maximize the profits. You have to sell the optimal number of what do you call mix of products. You are producing a lot of supplying equipments to different car manufacturers. Let us say you are producing 4 or 5 types of tires. Okay, and you are asked to maximize the profits for the company depending on the demands that are coming from the different car manufacturers. Okay, so how many tires of types A, okay, will be X1. How many tires of type B will be X2? Okay, like that, XN, so many different tires. Okay, 4 different car manufacturers means 4 different types of tires you have to give. So different quantities of tires. Okay, then C1, C2 will be different. Um, quantities on top of that. Okay, like that it will be. Now conditions will be there. Okay, for example, that first car manufacturer, he is putting some conditions. He is telling you, I must get at least 1,000 tires of this type and that type. Okay, 1,000 front tires and 1,000 back tires I must get. So front tires will become A11X1 and back tires will become A12X2, like that. Okay, car company 2 is telling, I need the the 4 types of tires. Okay, and he's telling, so X3, X4, 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 X5, all that will also come in. Okay, and like that it will come in. So different kinds of conditions. 4 car manufacturers, each of them giving 4 different conditions. Okay, one fellow is telling, I need at least 1,000 tires. That means greater than or equal to 1,000. Another fellow is telling, don't give me more than 1,000 tires. Okay, he is telling, so less than or equal to more. Don't give me more than 500 tires. So he is telling less than or equal to 500. So that will be another condition. And so tires, number of tires of X1 type, number of tires of X2 type, number of tires of X3 type, number of tires of X4 type. So all 4 types of tires, which one you will give? All of them together should be less than 400. Okay. Now the A1, A2 might be the cost of the tires. Okay. In which case B2 might be the total amount that you can bill, and B1 might be the total amount you can bill. So under all these constraints, you have to maximize the profits. Okay, so number of tires you sell, the cost at which you sell one tire, let us say that is C1, the cost at which you sell tire X2 type, that is say that is C2. So C1 X1 plus C2 X2 plus C3 X3 plus C4 X4. Okay, now all that together, all the 4 types of tires at their different costs, you must maximize. So that is your Z function. It is called object function. What is it called? Object function.
Object
Okay,
function.
that maximization will be subject to following conditions. You cannot simply produce any type of tire and sell it, because the 4 manufacturers only are your customers, and each of the manufacturers is telling, don't give me more than 1,000 tires, or give me more, at least 500 tires of this type and that type. So different conditions they are all putting. All the conditions become one line here. Okay, then X1, X2 and X1, X3, X4, let us say 4 types of tire. X1 must be greater than 0, X2 must be greater than 0. Okay, this is what is called the non-negativity restriction. So number of tires that you sell must be positive. Okay, you cannot have negative values. What does the negative value mean? It means nothing. It means, he is selling you the tire. Okay. So you must sell him the tire. So all the values x1, x2 up to xn. In this case, our example case, there are four types of tires. So x1, x2, x3, x4 quantities of the four types of tire. Everything should be at least equal to or greater than 0. You understood? Okay. This is the situation. So that short form only we are giving. Maximize or minimize. See, you can minimize or you can maximize. For example, you can say maximize the profits. Another situation, you can say minimize the costs, or you can say minimize the production. Something you can say. So either it will be maximize or minimize. Some optimum you must reach. Okay. So what is a short form of the LLP? Long form is like that. Short form of linear programming problem is Z is equal to J is equal to I to N Cj xj. Okay, that means C1 x1, C2 plus C2 x2 plus C3 xp plus Cn x1 xn. Okay, that is the whole thing. That is the function that is to be maximized. Okay, subject to the constraints. What are the constraints? J equal to 1 to n again. A of ij xj. A of aij xj. That means a11 x1, a12 x2, a13 x3. See, like that it is coming. A11 x1, a12 x2, a13 x3, like that a1n xn, like that it is going. So that is j equal to 1 to n, and I is equal to 1, 2, 3 up to m. Okay, so there are m conditions or constraints. M different types of constraints. You have to maximize the value or minimize the value of z. Okay, plus there is one more condition. Okay, one more condition is the non-negativity restrictions. All your decision variables. Okay, x1 is a decision variable. Why is it called decision variable? X1 is the number of front tires. X2 is number of back tires for, let us say, the small car. Okay, X3 is the number of front tires for big car. Okay, or X1 is for Ford tires. X2 is for Ford back tires, and X3 is for Hyundai car front tires. X4 is for number of tires for Hyundai back tires. Okay, so why this x1, x2, x1 is called decision variables? Why? Because what you are deciding in your manufacturing, how many x1 to manufacture?
Okay,
What
how
is
many
x1?
tires to manufacture?
Number of tires are front tires for Ford, number of back tires for Ford. Okay, you are going to take a decision on that only. That is why it is called decision variables. Okay, but this z is something to be maximized. Z is not just about decision variable. C1 is, let us say, the cost of that first tire. C2 is the price of the first tire. C2 is the price of the second tire. Then C1, X1, C2, X2 and all will become the total amount of billing that you do. So they are telling you, you manufacture the tires for these four fellows in such a way that you maximize the profits. Okay, then that is Z function. That is the objective function. Okay, so X1, X2 and all are decision variables. Z is the objective function that you need to maximize or minimize. Either they will say minimize the cost or they will say maximize the profits. Usually that only they will say. Okay, so that is why this is called objective function. Something to be optimized, either maximized or minimized is objective function. Then what you are calling, then you are talking about the decision variable. J is equal to 1 to 3, x1, x2, x3, x4, yeah, whatever, however number of tires you are manufacturing. Okay, the number of each of those tires is a decision variable. Then there is something called constraints. Okay, the constraint only is this one, a11 x1 plus a12 x2 plus a1n xn. Okay, so there are certain limitations on the use of the limited resources. Okay, that is only called constraints. So we told you, no, the altogether must be less than or equal to 10,000. Let us say the budget for manufacturing type 1 tires for Ford is only 10,000 rupees. Then that becomes a constraint. Within that constraint, okay, number of x1 type tires, x2 type tires, x3 type tires you are going to manufacture. Okay, and each at what cost you are going to manufacture. All that must together must be less than or equal to B1. Okay, like that. Okay, that is a constraint. Then solution. What is solution? A set of values of decision variables, no, x1, x2, x3, which satisfy all the constraints of the problem. Okay, see, all these constraints are satisfied. Okay, like that. This all these constraints are satisfied. You are also satisfying Hyundai's constraint that no, it must be produced. Total cost must be less. Bill must be less than 10,000, or total number of tires must be greater than 1,000. With or every month, the total number of tires must be greater than 1,000. Something like that. Okay, all these constraints are satisfied. Then you get a solution. You are maximizing the profit in such a way that all the conditions are satisfied. Okay, then only solution. A set of values of the decision variables that satisfy all the constraints of the problem as well as the non-negative restrictions is called a feasible solution. See, feasible solution is the last condition. Can you see this one?
Yeah, uncle, I can.
This condition.
Yeah.
Okay, that means number of tires type 1, number of tires type 2, number of types of tires of type 3, and number of tires of type 4. All of them must be greater than or equal to 0. They cannot be negative. So something of that must happen. Okay. When you satisfy that condition, you are reaching a feasible solution. That is called non-negativity restrictions. Okay. Everything must be greater than 0. This is also part of the constraints, but this is special constraints. This will go in every type of problem. In every problem, you will have these constraints, non-negativity restrictions. So once you satisfy non-negative restrictions, your solution becomes a feasible solution. Okay. Then what is optimal solution? Optimal solution is when you actually get a maximum value for Z. Okay. When you actually get a maximum value for Z. Suppose you are saying, sir, I am able to make a profit of 2 lakhs, sir, every month. You are able to say that. Okay. Very good. The top manager is telling, oh, excellent, man, 2 lakhs per month to profit just with the tires, or 20 lakhs profit or something. Okay, you are maximizing the number of sales of X1, X2, X3 in such a way that you are getting 2 lakhs profit. Previously, they were only getting 1 lakh profit or only 10 lakh profit. Okay, you are able to maximize it to 20 lakhs profit. Okay, in that case, it becomes an optimal solution. Okay, you understand what is optimal solution. Then you have to understand what is feasible region. Feasible region you are taking a graph. Okay, you are taking a graph. Now what happens? All this this one, no, C1 plus X1 plus C2 X2. Okay, let us say 3X1 plus 2X2. Okay, that is Z. That is Z. Okay, then let us say one constraint. One constraint is 3X1 plus 5X2 is one constraint. Then another constraint is 4X3 plus 5X4. That is another equal to is less than or equal to 10. Is or less than or equal to 1,000. Is less than or equal to 500. Like that, some other constraint is there. Each of this is a line. You understand? This is one line. This is another line. Okay. Now, when you draw a graph with all these lines like that, one line will come like that. No, one line will come like that. Another line will come like this. Third line will come like this. What happens? This region becomes the feasible region. Okay. Your solution is lying somewhere within this feasible region. What is the optimal solution in this feasible region? In this region, if you take this point, you are going to get a feasible solution. You are going to get a feasible solution. Here also you are getting a feasible solution. But which is the optimal solution? Optimal solution might be this point where your 20 lakhs profit is coming. You understand? Or optimal solution may be this point at the end where you are getting even more, 30 lakhs. Oh, 30 lakhs profit I'm getting. That is the optimal solution. So feasible region is the region within which all the solutions can be obtained. And one of the points in the feasible region will be the optimal region. Okay, optimal solution. Okay. I think you understood everything. Very easy. Now we can go for some problems. Okay, first how to mathematically formulate the linear programming problem. The procedure for mathematical formulation of a linear programming problem, LPP problem. It consists of the following steps. Okay. First thing you have to do is identify the decision variables. First of all, you find out what are the quantities that you have to produce, or what are the quantities you don't have to produce, what they are asking you to do, that thing, no decision variables. Okay. In our example case, number of tires of type 1, number of tires of type 2, number of tires of type 3, number of tires of type 4. These 4 are the decision variables. So identify that first. We given the problem. Hey, on the decision variable. What is the thing as a manager I am supposed to take the decision on? It may be the number of days you are working. It may be the number of units of tires you are producing. It may be the amount that you are asked to spend, whatever. That will be the decision variable. Based on problem to problem, it will change. Okay. Then identify the objective function to be maximized. What is Z? You have to find out. Okay. Suppose they say the top manager has told you, hey, make the profit maximum. Okay. Then he is telling that type 1 tire is sold each one 5,000 rupees. Type 2 tire, each one is sold for 7,000 rupees. Okay. Then what is the maximum profit? Our type 4 tire is for 10,000 rupees, X4. And type 3 tires is sold for 2,500 rupees, X3 type. Okay. All this X4, this one, the whole thing must be maximized. That means Z is this one. Objective function Z is the thing that must be maximized. Okay. The maximized or minimized. Okay. Your cost is minimized or profit is maximized usually. And then express it as a linear function of the decision variable. See, like that we have done now. Now, third point is to identify the set of constraint conditions and express them as linear inequalities. Okay, because either it is less than or equal to B1 or greater than or equal to B2. Okay, so it is inequalities. This one is called inequalities, less than or equal to or greater than or equal to. So identify the set of constraints and express them as linear inequalities. That also should be expressed linearly. Because why we saw A1 x1, A2 x2, A3 x3, like that. No conditions are going. Then A11, A12, A13, then A21, X1, A22, X2, like that it's going. Okay. So plus, less than or equal to B, like that. Okay. So that is also a linear function. So that also you write as an equation. Okay. That's all. When you have done this, you have got the problem. Linear programming model you have got. What you have got? See, there is no answer to this. Okay. No calculation to be done and find an answer. No. All you have to do is identify decision variables, then get the objective function Z is equal to what, which one has to be maximized in terms of linear variables, then identify the set of constraints, including the non-zero constraints. Okay, what we saw, no, we have to have non-negativity constraints are there. Okay. Non-negativity constraints, restrictions. In blue, I have put that. So non-negativity restraints also including, you must include that. Okay. And then you will get the solution. And when you have written it like that, then you have written it very easily. That is the model. That is the LLP model. Okay. You understand? There is no calculation to give. There is only a model that has to be given. Okay, let us do one example. You will easily understand. That's all matter. That's all matter. Let us do example. 4 examples or 5 examples today. Okay, 4 or 5 examples we'll do today, and you will understand. Okay, first example: a furniture dealer. That man means table, chair, glass, bureaus. What else? Stools and rocking chairs, all of that. No, furniture dealer. He deals only with 2 items, but this fellow only 2 items. Tables, only one type of table and one type of chair he is doing. He has to invest 10,000 rupees. Okay. And he has to have a space to store at most 60 pieces. Okay, now this becomes a constraint. Immediately we can see. Can you see or not? What is a constraint? a space to store at most 60 places. So, okay, only 60, less than or equal to 60 items only you can store. Okay, then he has to invest 10,000 rupees. Okay, that means you cannot buy more than 10,000 rupees worth of tables and chairs. That is another constraint. Okay, immediately you can find out what the constraints are. How do you find out what the decision variables are? Formulate this problem as an LLP so as to maximize the profit. Okay, what they are asking, Z is equal to, you must maximize the profit. Okay, what is profit? Okay, how you get the profit? A table cost him 500 rupees, chair cost him 200 rupees. Okay, now what you have to do? How many tables and how many chairs we have to sell? That is what you have to take a decision. At what cost? Okay, this is 500 rupees, this is 200 rupees. Okay, these are all constraints. How many tables and how many chairs you can sell in order to get the maximum profit? Okay, so let us keep the number of tables you can sell as x1 and the number of chairs you can sell as x2. You have to find out what is x1, what is x2, and what combination of x1 and x2 you will sell in order to make the maximum profit. So Z max will be the profit. Okay, let variables x1, x2 denote the number of tables and chairs respectively. Okay, objective function is what? Okay, the profit on x1 tables. What is the profit on x1 tables? He is getting 50 rupees profit per table. Okay, suppose x1 tables he is selling means, then profit on each table is 50 rupees. Okay, then the profit on every chair is 15 rupees. So x2 chairs he is selling, then each chair is getting a profit of 15 into that one. Okay, so this one plus this one should be maximized, So Z is equal to the objective function you have arrived at already. This is the objective function.
Yeah,
Okay.
okay.
First one, you identified the variables, number of tables, number of chairs. These are the decision variables. So decision variable x1 and x2 is here. How many tables you have to sell and how many chairs you have to sell in order to maximize the profit. So maximizing the profit, this is the objective function you have found out. Okay. So first part of the problem has been solved already. So let Z is equal to 50x1 plus 15x2. That's all. First part of the solve. You have solved. Okay, what is the second part you have to solve? So total profit has to be maximized. We have to maximize Z equal to 50x1 plus 15x2. That is the first part. Then identify decision variables over. Identify objective function over. Third part is identify the set of constraints. Okay. Now, what are the constraints? I told you already. You cannot store more than 60 items. Okay, that means what it will be? Number of chairs plus number of tables plus number of chairs should be less than or equal to 60. This is one constraint. So this is constraint one. Another constraint is he is buying the chairs and the tables. Okay, what is he buying the chair for? Cost of table. One cost of table is 500 rupees. Okay, so total cost of tables will be 500 into x1. Then he is buying the chairs for 200 rupees. Each chair costs 200 rupees. He is buying x2 number of chairs. He has only 10,000 rupees. So this cannot exceed 10,000. Okay, this is the second constraint. Constraint number 2 is this one. Okay, that is what is put here. Okay, this is wrong. This is not table. Okay, this is not table. Your book is wrong. This is chairs. Okay, you understand? This is not table. You correct it in your textbook. This is not table. This is chairs. Okay,
Yeah.
Number of chairs equal to rupees 200 into x2. Number of tables equal to 500 into x1. Total cost he spends on tables. Total cost he spends on chairs. Total cost of the everything, how much he buys. Okay, that total cost equal to both of these together. That cannot be more than 10,000 because I am only 10,000 rupees. So this is the constraint function. 500 x1 plus 200 x1 must be less than or equal to 10,000. இததான் வந்து அங்க வந்து b2 less than or equal to b2 ன்னு போட்டுனேன் ரைட்டா. a1 1 x1 plus a1 2 x2 less than or equal to b2 னா இதான் அர்த்தம். புரியுதா? 500 x1 plus 200 x2 less than or equal to 10,000. Now you understood what you was telling abstractly. This a11 is only 500. This a12 is only 200. Okay, a11 is the cost of a table, a12 is the cost of a chair. So depending on what decision you are called to take, what is the situation you are handling as a manager, okay, a11 a12 a21 a22, all that will vary. x1 x2 will vary, decision variables will vary, constraints will vary, okay, and b1 b2 up to bm will vary. Number of constraints also will vary. Sometimes you might have only 2 constraints, sometimes you will have 3 constraints. But suppose we are giving manufacturing to 20 car manufacturers, so all the tires in India you are only manufacturing, you are MRF. Okay, if you are MRF and you are manufacturing all the tires for all the cars, then you might have 20 sets of constraints. M might be equal to 20. Okay, very complex set of constraints, and you have to model. So this is the model. Okay, then one more thing I told you, every problem, every model, non-negativity constraints must be there. So number of tables and chairs cannot be negative, you must have only positive. So x1 must be greater than or equal to 0, and number of chairs x2 must be greater than or equal to 0. Number of tables greater than 0, number of chairs greater than or equal to 0. So when you have this also, you got everything that is necessary for the model. So your model is complete. When you complete the model, how will you write it? This is how you will write it. This is all, this is the model. Okay, what I have highlighted in blue, that is the model. This is the answer. You must give your answer like this. If you give your answer like this, you will get 10 out of 10. If you don't give your answer like this, you won't get correct marks. Maximize. What is to be maximized? Object function to be maximized is z equal to 50x1 plus 15x2, that we found out. Subject to the constraints, to every constraint you must now one by one elaborate. x1 plus x2 must be less than or equal to 60. Okay, 500 x2 x1, see how you ended up this way. 500 x1 plus 200 x2 is less than 10,000. You divide everything by 100. 5 you divide by 100, you divide by 100. Okay, that's why it became 5x1 plus 2x2 less than or equal to 100. That's all. Okay, so the condition in its final form you are putting here. This is constraint 1, this is constraint 2, this is constraint 3, this is your object function. Okay, once you write like that, this last constraint, the negative constraints, minimum value constraints must be put in the last always. All other constraints must come before that. Okay, that is a example and it is solved. You understood now? There is no calculation and final answer and all like that. Okay, oh, you give one answer. No, this is a model. Okay, this is a model. All these statements together are a mathematical model of the real life situation you are facing as a manager. You are understanding? It's very advanced mathematics. Okay, this is quite advanced mathematics. So far till 10th standard, you are only okay, solution, you an answer, correct answer, wrong answer. No, here is also correct answer, but this correct answer is a whole set of mathematical statements, a whole set of mathematical statements that are a model, that are a numerical model of the real world situation you are facing. This is a decision you have taken, but you have taken a mathematical decision now. Okay, it's beautiful. You are enjoying this. I don't think you have come across anything like this kind of problem solving so far in maths. Okay, the first time. That's why I told you operations research is beautiful, very lovely. Okay, now let us go to example 10.2. Okay, we'll do at least 4 examples today. We'll try to do that. Okay, company is producing 3 products, P1, P2 and P3. Okay, with profit contribution of 20 rupees, 25 rupees and 15 rupees per unit respectively. The resource requirements per unit of each of the products and total availability are given below. Okay, all these are constraints. Okay, number of man hours for P1, this is a constraint. That means you can make a man work only 6 hours to produce P1. Okay. Is it a constraint or not? You
Yes,
can
uncle,
get
it's a
a man,
constraint.
it will take 6 man hours to produce P1. Okay. It will take 3 man hours to produce P2. It will take 12 man hours to produce P3. Okay. These are all constraints. Okay. Then you need to have a machine working for 2 hours to produce P1. That is also another constraint. You need another machine working 5 hours to produce P2. Then you need a machine working 4 hours to produce P3. That is also a constraint. Okay. Then total availability are given below. Okay. That is also, let us see. The resource requirements, each unit of the product, and total availability. Let us see. Total availability is a constraint. We'll see. Okay. Okay. Material that is used. Okay. In order to make one product P1, 1 kg of raw material is used. That is a constraint. You need 1 kg of raw material. For P2, you need 2 kg of raw material. For P3 product, you need 1 kg of raw material. Okay. These are also constraints. Now you have to formulate the above as a linear programming model. Okay. Total availability maximum, okay, less than or equal to 200 and less than or equal to 350, less than or equal to 100. Okay, these are also constraints. So all this is there. Now let us see how the problem is worked out by your textbook. Okay, very interesting. Let x1, x2 and x3. What is the problem asking? Formulate the above as a linear programming model. So first of all, we have to identify the decision units, correct? So they must be the variables, the decision variables. Okay. How many units of P1? How many units of P2? How many units of P3? Okay. Those is the decision variables. How many units of P1? How many units of P2? So X1, X2 and X3 are the decision variables. What are the decision variables? Number of units of product P1, product P2 and product P3 to be produced. Okay. And is assuming that you are going to maximize the whole thing. Okay. Because company is producing 3 products. What will be this expectation? What will the products maximum loss produce பண்றான்னு சொல்வாங்களா? இல்ல. Maximum profit maximize பண்ற மாதிரி இந்த 3 products produce பண்றான்னு தான் சொல்வாங்க. So our function Z will be the maximizing of the number of units of P1, P2 and P3 given the following constraints. Okay. So profit on X1 units of the product. How you know profit of X1 units on the product? Because the profit is 20 rupees. Okay. Is given here. What is given here?
20 rupees.
X1 units you are producing of P1, X2 units of P2, X3 units of P3. Okay. If you are producing X1 units of P1, then 20 rupees you are selling it for profit. Then 25 of X2, 25 rupees, 15 rupees plus. Okay. So if you want to maximize this, then the maximum profits is 20 X1 plus 25 X2 plus 15 X3. You got your objective function. What you got? You got your objective function. The decision variables are X1, X2 and X3. You got your decision variables also. Now what you have to do? You have to only put the constraints. Okay. You have to only put the constraints. Okay. So profit on X2 units is 25X2. Profit on X3 units is 15X3. Total profit is equal to X1, 20X1 plus 25X2 plus 15X3. So since the total profit is to be maximized, we have to maximize Z is equal to 20X1 plus 25X2 plus 15X3. Okay. That is the object function to be maximized. X1, X2, X3 are the decision variables. Now let us look at the constraints. Okay. What are the constraints? 6X1 plus 3X2 plus 12X3 less than 200 is telling. Why? Total availability of the man hours is 200. Okay. You have to distribute only 200 man hours available. Only 350 machine hours available. Only 100 kilo of material available. Okay. So if you are producing P1, X1 units of P1, each will take up 1 kg into X1. So it will take up how much? 1 into X1 kg it will take up. Okay. You are producing X2 kg. We don't know. That is optimal. You have to find out. That will take up 2 kg. Okay. Then if you produce X3 units of product 3, that will again take up 1 kg each. Altogether must be less than or equal to 100 kg. Okay. Because only 100 kg of raw material manufacture. So this becomes constraint 3. Same way, constraint 2, what you can do? Machine hours. Okay.
Machine hours 2 into x1.
2x1, correct. Very
plus
good.
5 into x2 plus 4 x3 less than 350.
Very good. Less than or equal to 350. Constraint C1 will be what? Man hours.
6x1.
6 hours you are giving for x1.
Plus 3x2.
3 hours you are giving for x2.
Plus 12 x3.
12 hours you are giving, man hours you are giving for x3 units. Okay. Totally how many units?
200.
It should be less than 200 man hours. Okay. It should be less than 200 man hours. Then what negativity constraints? What is that? X1 should be greater than or equal to 0. Number of production of product 1 should be greater than or equal to 0. Number of products P2 produced should be greater than or equal to 0. Number of products P3 produced should be greater than or equal to 0. All these are the constraints. So C1, C2, C3 constraints plus this is C4. This is common to all the problems. The final constraint in all your problems will be the non-negativity constraint. Okay. So once you do that, you have finished the model. Okay. The maximizing profit thing was 20x1 plus 25x2 plus 15x3. This is Z. This is the maximum profit. Okay, maximum profit. So this is Z condition, object function. These are the constraints C1, C2, C3, and C4. You give this as a model by telling that the problem must be solved in such a way that Z is maximized as 20x1, 25x2, and 15x3 is maximized, subject to the conditions C1 that 6x1 plus 3x2 plus 12x3 is less than or equal to 200, and subject to the condition that 2x1 plus 5x2 plus 4x3 is less than or equal to 350, subject to the condition x1 plus 2x2 plus x3 less than 100, and subject to the condition that x1 greater than or equal to 0, x2 is greater than or equal to 0, x3 greater than or equal to 0. Once you say that, you're given the answer. That's all. Tough or easy?
Easy only, answer.
Easy only. What is the only tough thing here? To find out what are the decision variables. Once you find out the decision variables, then you can work out everything else. Okay, so let us see how he is giving the solution. He is giving the solution here. This is the mathematical model he is giving here. Correct? Maximize Z. 20x1, 25x2, that is only Z. Maximize. Subject to 6x1 is less than or equal to 200, then less than or equal to 350, less than or equal to 100, and x1, x2, x3 greater than or equal to 0. This whole thing is the answer. Boss, all these 1, 2, 3, 4, 5 lines. This 5 lines together is the answer. If you leave out anything, you won't get 10 out of 10.
Okay.
Okay. This is the answer. Okay, the mathematical model. Okay, let us do example 3. It's slightly more complicated. Okay, not very complicated, slightly more complicated. Now, a dietitian wants to mix 2 types of food. Okay, this fellow is having 2 types of food. Let us think. Let's take the whiteboard and do that, so that we can come out of the textbook and we can enjoy. So he's having 2 types of food. Okay, what are the types of food? F1, F2. Okay, in such a way, you wishes to mix them that the vitamin contents of the mixture contain at least 6 units of vitamin A and 9 units of vitamin B. Okay, 6 units of vitamin A. No. At least there must be 6 units of vitamin A, and at least there must be
9 units of
9
vitamin
units
B.
of vitamin B. Okay, so what is the problem? How many kgs of x1 kgs of food 1 and the x2 kgs of food 2 you have to produce in such a way that this is vitamin A constraint. Vitamin A constraint. This is vitamin B constraint. Okay, you have to produce a combination of A and B in such a, x1 kg of f1 and x2 kg of f2 in such a way that is greater than 6 for vitamin A and greater than 9 for vitamin B. Those are the constraints. Okay. So, okay, now what you have to do? Food f1 at the same time you have to minimize the cost. Okay, here what is that? You have to minimize the cost. Okay, Z is a min function. Okay, what is Z min? The object function, that also you have to find out. Okay, now what are the costs? X1 is costing 50 rupees per kg. 50 into X1. Okay, then F2 is costing 70 rupees per kg. So this must be minimized. Okay, Z is equal to, this must be minimized. So you got your decision variables x1 and x2. You got your object function 50 x1 plus 70 x2 must be minimized. Okay, minimized in such a way at the same time that constraint 1 and constraint 2 are followed. How to write constraint 1? Vitamin contents of the mixture contain, food 1 contains 4 units per kg of vitamin A. Okay, so you x1 kg, food 1 contains 4. Each kg contains 4. So total amount of vitamin when you produce x1 is 4 into x1, and 6 units of, and F2 contains 5 units per kg of vitamin A. Okay, 5 units per kg of vitamin A. So your constraint becomes 4x1 plus 5x2 greater than or equal to 6. So with the help of x1 kg and x2 kg, you must produce so much in such a way that they become greater than or equal to 6 kg of vitamin A or 6 units of vitamin A. Okay, then food 1 contains 6 units of vitamin B. 6 units of vitamin B contains food 1. Food 1 is x1. Okay, so 6 x1 into 6 units. Okay, and x2 contains food f2. Food f2 contains 3 units of vitamin B. Okay, so number of kgs into 6 units per kg. Number of kgs into 3 units per kg of vitamin B. That should be greater than or equal to 9. Okay, so these are the constraints C1 and constraint C2. This is C2, this is C1. Okay, now you have to formulate the answer. Okay, let us go back to the text and see how is formulated the answer. Z equal to 50x1 plus 70x2 வருதான் முதல்ல பார்க்கலாம். Okay, is put some tabular column and all of that. Then he is also telling 4x1 plus 5x2 greater than or equal to 6. What we have said? Yes, we have said the same thing. 4x1 plus 5x2 greater than or equal to 6, we have said. Then what he has said, 6x1 plus 3x2 greater than or equal to 9. We have also said 6x1 plus 3x2 greater than or equal to 9. So the constraints are correct. What about the object function? Object function, where it is? Non-negativity, yes, x1 must be greater than 0, x2 must be greater than. Number of kilos of food 1 must be greater than 0. Number of kilos of food 2 must be also greater than 0. That also we are having. And what? Minimize. Z equal to 50 x1 plus 70 x2 should be minimized. 50 x1 plus 70 x2 should be minimized. Yes. So that is all is done. And so mathematical final model is these 3 lines. Minimize z, which is a function z equal to x 50 x1 plus 70 x2, subject to the constraints. Constraint 1 is 4x1 plus 5x2 is greater than or equal to 6. This is the vitamin A constraint. 6x1 plus 3x2 is greater than or equal to 9, which is the vitamin B constraint. And then the negativity constraints. Non-negativity constraints are x1 and x2 greater than or equal to 0. You understood? Okay.
Yeah.
Okay, let us do example 10.4. Shall we do it? We have 10
Yeah,
minutes.
yeah,
We can do it. We can do it fast. Okay, slightly complex problem, but let us do it. A soft drink company has 2 bottling plants, C1 and C2. So here is our soft drink company, and they are having 2 bottling plants. Okay, C1 and C2. Each plant produces 3 different soft drinks, S1, S2, and S3. The production of the 2 plants in number of bottles per day are given. Okay, constraints. Okay, in plant C1 you can produce 3000 S1 bottles and 1000 in the plant C2 you can produce 1000 S1 cool drinks. In plant C1 you can produce 1000 S2 cool drinks. Plant C2 you can produce 1000 S2 cool drinks bottles. In plant C1 you can again produce S3 type, no, third type of cool drink, 2000 bottles you can produce. And in plant C2 you can produce 6000 bottles. Okay, that is given. Market survey indicates during month of April, this is all number of bottles per day. Okay, what is this? Number of bottles per day. Okay, a market survey indicates during a month of April there will be a demand. April month, how many days are there?
30, uncle.
30 days are there in April month. Okay, so in the month of April there will be a demand for 24,000 bottles of S1, 60,000 bottles of S2, and 48,000 bottles of S3. Okay, now the operating costs per day of running the plant C1 and C2 are respectively 600 rupees and 400 rupees. How many days should the farm run each plant? Okay, now we are come to the decision variables. What are the decision variables? Decision variables are how many days to run plant C1, that is equal to X1. How many days to run plant C2 equal to X2 days. Okay, these are the decision variables. Okay, now from that you can go for the Z1 or the object function that is to be maximized. Okay, what is telling constraints and maximization? The operating cost per day of running plants C1 and C2 are respectively 600 rupees and 400 rupees. Production cost to be minimized. Okay, so the Z function is a minimizing function. What is the function? Not maximizing function, minimizing function. And what are the values A1 and A2? A1 is 600 and A2 is 400. Okay. A1 is 600. A2 is 400. A11, A12 is 400. So A1 1 into X1 plus A12 into X2 is equal to, okay, should be minimized. Okay, sorry, should be minimized. C1 plus C2 must be C11 plus C1 plus C2 must be minimized. Okay, what is C1 600? If you operate factory C1 for X1 days, then the cost of operating that factory is equal to how much? 600 into X1. If you operate the factory C2 and decide to operate it for X2 days, operating cost is 400. Okay, now this must be minimized. So this is the objective function. Okay, objective function you got. So 600 rupees into number of days you are operating C1. Okay, and 400 into number of days you are operating C2. That should be minimized. Those are the objective function you got. Now what about the constraints? You must minimize the cost of operating in such a way that the demand is met. What is the demand? That is very important. Okay. You must at least produce what? 24,000 what? 24,000 S1. Okay. You must at least produce 24,000 S1. Okay. That means if you operate this C1 for X1 days, then every day you are producing 3,000 S1. Okay. S1 is a constraint. Constraint 1. S1 constraint is C1. Okay, C1 is equal to, okay, X1 days you are operating, it will produce 3,000 bottles of S1. Okay, and then what it will produce? $24,000 bottles of X1. S1 is requested. Okay, C2 will produce 1,000 bottles. So X2 days you are running factory 2. Okay, that will produce 1,000 each day. Okay, so totally you will be producing X2 into 1,000 plus X1 into 3,000 bottles. Now that must meet the demand. The demand is 24,000 bottles of C1, S1. So that 3,000 X1 plus 1,000 X2 must be greater than or equal to 24,000. So this is one constraint, C1. Okay. Then the other constraint is arising due to the demand for S2. How much is the demand for S2? That is greater than or equal to 16,000. Okay. That means you are operating factory 1 for X1 days. It is producing 1,000 bottles each day. So total number of bottles produced by factory 1 is 1,000 into X1. Same way you are operating factory 2 for X2 days, and it is producing 1,000 bottles of S2 each day. So 1,000 X1 plus 1,000 X2 must be greater than 16,000. This becomes your second constraint. Same way, S3, the demand for S3 is very great. Demand for S3 is 48,000 bottles. Okay, 48,000 bottles. How you will manufacture? You should be in such a way that if you are putting X2 days, then it is manufacturing 6,000 units of X2. Okay, and it is manufacturing 2,000 units for each day. So X1 days into 2,000 units. X1 days into 2,000 units plus X2 days into 6,000 units per day should be greater than or equal to 48,000 bottles. So 6,000 bottles per day into X2 days plus 2,000 bottles per day into X1 days must exceed 48,000. These are the three constraints. What are the minimized constraints? X1 must be greater than or equal to 0. X2 must be greater than or equal to 0. Number of days X3. Okay. So number of days of operating so no, not X2. Okay. Number of days of operating factory 1 or C1 must be greater than 0. Number of days you operate X2 must be greater than 0. Okay. This is the final one. This is the fourth condition. Once you have done all of this, you have got the mathematical model. Okay. That is the answer. What is the answer? Let us see whether there is a correct answer in your book. Example 10.4. Okay. Very good. We are doing all the things correctly. Example 10.4. Minimize Z. 600 x1 plus 400 x2. Have you got that? Yeah. Minimize. Down arrow we have put. Okay. 600 x1 plus 400 x2. 600 x1 plus 400 x2 must be minimized. Subject to the constraints. Okay. What are the constraints? 3000 x1 plus 1000 x2 greater than 24,000. 3000 x1 plus 1000 x2 greater than equal to 24. Yes. Then what you are doing? 1000 x1 plus 1000 x2 greater than 16,000. Okay. 1000 x1 plus 1000 x2 greater than 16,000. That also correct. Third one here is telling 2000 x1 plus 6000 x2 greater than 48,000. 2000 x1 plus 6000 x2 greater than 48,000. Okay, that is also there. Then what is the fourth condition? X1 and x2 are greater than 0. That is also there. Okay, we have found the complete model. What is the answer? The following is the LPP model. So minimize Z. This whole thing is the LPP model. Okay, this is the whole answer. Correct? Fantastic. I think by now you understood how this whole thing functions. Okay, and you must enjoy this because first time in life you are doing actually a mathematical model. Now only you'll understand the power of mathematics. So far you have been thinking you have to calculate and give one answer. That is only maths. No. Maths is about taking a real world decision making complex situation and reducing it to a numerical model. That is the greatness of science. So that you can take decisions. Based on this, you can easily take decisions. Okay. So now you are industrial manager. You are on the floor. You are managing both. You are in charge of Coca-Cola company manufacturing. You have two plants under you. Okay. One is Fanta. The other is Coke. The third one is whatever. What is the third one?
Sprite.
Sprite. Okay. So you take the decision now. Okay. I hope you enjoy this class.
Yeah.
We'll see again on 9th, 2 days later. Okay.
Okay.
Saturday. Yeah. Saturday we can do 4 to 5, man, because I have that class.
Saturday 4 to 5, uncle. Yeah, I'll try.
Otherwise, in morning, if you can do, even better.
Morning exam, no, uncle. That's why.
Okay, Saturday 4 to 5 we'll do. Because I have to go to Attipettu, very far away. In order to handle slum children, poor children, I have to do that class for them.
I'll try to come as early as possible, uncle.
Okay, okay. Thanks, man.
Uncle. Bye. Good night.
Bye. Good night. Thank you.